Hi. Officially, thanks for joining me today. Welcome to the SCAG GIS training session for the local planners. So let me briefly introduce myself. My name is Do Kim. You can call me Do. I'm a faculty member at Cal Poly Pomona Urban and Regional Planning Program. And I have been with the Cal Poly Pomona like for 15 years. For that 15 years, I've been teaching GIS. Actually, the first GIS class that I took was 1997. So ArcView, first desktop GIS, was released to the market in 1992. So 5 years later, I took my first GIS class. Since then, as soon as I taking the GIS class, I was kind of fell in love with the GIS, and since then my entire career was based on GIS. I have learning GIS, I have researched for the GIS, I have used the GIS for the planning practice, you name it. I've done a lot of things. The first professional position that I got it after my master's degree was the GIS associate, not in the planning sector, but in the IT company, .com company. I worked as a GIS associate, and then after that, I've done almost everything that I can do with the GIS. So I am very confident with the teaching GIS. Hopefully, I can manage this session with a very, a comfortable, enjoyable environment. I hope everybody has fun with this, learning GIS. Only my concern from my personal experience is that teaching GIS teaching GIS via Zoom is a little challenging. Personally, I prefer in-person training, but unfortunately, I'm not able to manage the in-person training. So if you guys have any sort of concerns and any technical difficulty or anything like that, please let me know. Kind of like a bi-directional communication must be very, very important for us to manage this training. So please let me know if you have any questions or concern. And if I go a little fast, and I want you guys slow me down, okay? So that's me. And about this training session, actually, when I collaborate with SCAG, we discussed to design a GIS training session for the local planners. Planners in the municipal government. I believed the composition of these people in this room, is really varied. They not necessarily come from local government or municipal government. So that's my concern. But let's talk about that a little later. Let's talk about that part a little later. But I want you guys to understand that this training is designed for local planners and particularly local planners. Okay. Also that does not necessarily means that this training may be beneficial for all local planners. And the bottom line is that this training session covers the very intro level GIS skill set to up to intermediate level GIS skill set. So, Elizabeth, do you have a question?
Yeah, I'm sorry to interrupt you. I'm here with one of my staff members that we're just trying to get our feet wet. And um is it accurate that in order to use this software you have to have a PC, that it does not run on a Mac?
Yes, that's true. That's correct. So Mac does not, get along with the GIS, unfortunately.
Okay, so someone who doesn't
PC,
have a PC computer is not going to be able to attend this training.
yes, that's correct. So if you have like a
Oh.
MacBook or a Mac, whatever. I mean, I don't know the language because, as I said, my entire career is based on,
No, of course, no
yeah,
problem. I
right.
did not
So
realize that the software was not available on other types of computers other than PCs. So I apologize. Thank you for your time.
no. Okay, so that's a good question. So I mean, that's always me in my GIS class, kind of making fun of Steve Jobs, right? I mean, that's Steve Jobs' fault. That's not my fault, right? So yeah, one more time, if you need run this software, you need a PC, okay? Yeah, on the top of that hardware requirement, this class, this training session is designed for the local planner who learned basic GIS skill sets up to intermediate level GIS skill sets. Okay. So as I show you here, there's a lot of things that you can do with the GIS. I mean, I'm just listed just a few minor, not minor, but a few things that you can do with the GIS from introductory level to advanced level, right? But I am not able to actually cover everything that you can do with the GIS in this 2.5 days session. So I kind of try to super focus on very introductory level GIS skill set up to intermediate level GIS skill set. I mean, my challenge when I design this class is that I have to squeeze my 15 weeks intro GIS class into the 2.5 days. I mean, actually the content, the subject matters of this training session, it's little more than my introductory level GIS course. So I have to, I mean, to be honest with you, I have to squeeze, I have to say 20 weeks or 23 weeks of material into the 2.5 days. That was my challenge. So I have to pick real essence with real concise way. I have to put everything together. So unfortunately, I was not able to cover every things that we can do with the GIS from introductory to advanced level, right? So from my perspective, who would be the best, who would be the person that gets the best benefit out of this training was that, hey, I'm not the GIS person, right? I never learned the GIS. It's really first time to learn the GIS. I mean, that kind of planners may get very, good benefit out of this training. And little more than that, and if you say that, oh, I know basic GIS skill set, and I want to, expand my GIS skill set a little further to the like intermediate level GIS skill set. I mean, those kind of people, those kind of folks may, learn a lot from these training sessions, right? Another good group of planners that I was be able to think is that, hey, I took the GIS class. I kind of get exposed to the GIS. when I was in school, but it has been a while. My memories got rusted, and I want to refresh my memory, and I want to sort of like, rejuvenate my GIS skill set. Then those kind of folks will be really, really fit very well with these trainings. Okay. Last groups that I was able to think is that those of you guys using GIS still, and that those of you guys have used the GIS, but the software that you used is ArcMap or ArcGIS Desktop, the old version. As a lot of you guys may know that GIS, software has been migrating from the desktop GIS to the ArcGIS Pro. So, I know those functions, I know those tools, but I am not so familiar with all those interface of new software. Then, since I'm gonna use this new software, ArcGIS Pro, so you can learn a lot about ArcGIS Pro, right? So, those kind of folks. So I want you guys envision, where you guys are and how you guys are gonna learn, from this training and what you can learn from this training. Okay, so that's the way I design this training session. Okay. Oops. There's an overview there. So here, I mean, some of you guys may think that, oh, I'm not a local planner. So I've seen a lot of welcomes and say hello chatting going on in chat box. Some of you guys from, I know, like Caltrans and some other organization and institutes than the local, municipal government. Then you may want to think that, oh, then this training is not for me. I mean, I'm not going to be able to get out of anything from the training. Actually, that's not true. I mean, you can, get out of something from this
Oh, no worries.
training.
I forgot about it too.
Sorry. So my point is this. I mean, GIS in general is not only for the planners or not only for the local planners. I mean, GIS application can be goes on and on and on and on almost every industry and every areas of government and private and public sectors. So the reason why I says I designed this training session for the local planners that a lot of examples and a lot of cases that I'm gonna use in this training session is kind of fit with the local planners' everyday task and what they usually do in their everyday life, everyday task. So if you're not local planner or municipal planner, I want you guys to keep thinking of how can I apply this to what I'm doing, right? So my point is that it doesn't have to be for the local planners. I mean, what you guys are gonna learn and what we're gonna play with in this training session can be applied to any area. I mean, for example, I'm a transportation planner. I don't have a lot of experience with the local, planning practice, but I use the GIS, for the transportation analysis and environmental analysis, you name it. I use the GIS. So I want you guys to keep thinking of what you can do with this, right? What you can do with what you learn from this class in your task and what you want to do. Okay, then you can learn a lot, and this training can be very beneficial for you. Okay, so quick overview is that, as I said, this is like a 2.5 day session. Today we're gonna have only half day until noon, and tomorrow and the day after tomorrow we're gonna have a full day, 9 to 5. And what we're gonna actually, how I design these 3 days or 2.5 days is that first day today will be very, very basic stuffs about what is the GIS and what's the GIS data and how can we learn and how can we start a GIS project. Is that very basic intro GIS stuffs. And tomorrow, what we're gonna play with is that GIS data processing. If you want to edit, make editing or manipulating or manage your data, so on and so forth, then you may want to learn how to handle GIS data and how to process it and how to build it and how to analyze it and things like that. And then third day is that actually an application of what you learn in first 2 days. So third day is day 3 is the analysis, spatial analysis. So we can do the spatial analysis with a so-called something called vector data. I mean, I will explain what is this. And we're gonna do the spatial analysis with the rest of the data. So this is some application of GIS skill set. So, I wanna measure, let's say, for example, walkability. Or I want to identify the best location of new housing development in my cities and things like that. So there's some cases and scenario that I'm going to throw in, and we're going to use the GIS technology and GIS analysis to find some policy, some answers to the policy goals and so on and so forth. So that's a very, once again, like a local planners levels perspectives, okay? Oh, the most important piece of information, we gotta use materials for this training, including this PowerPoint. I emailed you, I reached out to you via email. I sent you the link that you can download the material. So if you have not received the email, I believe everybody must receive my email, but I'll also send you the link on the chat box. So I posted the link to that training folder. If you go that link, you will see, let me show the what you can find in the link. So please make sure to visit the link that I posted it in the chat box. Also, I emailed you. And if you go to the folder, you will see this material. So let me briefly explain the material in that folders, okay? So syllabus, the basic overview of this class, and software installation instructions if you need install the trial license, and if your institute does not provide you with the regular GIS license, you may want to take advantage of trial license. I mean, regarding this, I also reached out to you, explain how to install the software. So that instruction is right there. And another folders that you can find under that folder is lecture materials. In that lecture materials folder, you will see 3 PowerPoint files that I'm going to use in the training session. So the one that you guys see in the background right now, oops, the PowerPoint that you see in the background, this one is actually day 1 presentation. So basically, if you download the PowerPoint file, that you can also, this PowerPoint file also has a link to that folder, and basically you can kind of take a peek how I'm gonna manage this training session and what kind of subject matters in the training session in little further details, right? And then another file that you can find is that PDF file named ArcGIS Pro manual. I'm not going to use this manual in the training session, but this manual is for you after training session. So this manual has very detailed button clicking, step-by-step instruction of how to use software. Okay, so if I just skim through this manual, you can see I have very detailed. Hey, you're gonna do this first, second, third, all those details, all those details. Hold on, I have like a, yeah. So I mean, you can join me anytime you want. I don't have any, control, right? So I don't think you're gonna have a lot of problem with the following up the training, even if you joined, even if you missed some portion of training. Okay. So going back to the manual, as you can see, this is the very detailed, step-by-step instruction about how to use the software. Okay, so if you want to keep using the GIS after the training, this manual can be a good reference. So I want you guys download this and carry it with you, and whenever you need GIS software later, you can take a look at it and you can refresh your memory. Okay.
Hi, Doc. There was a
Yeah.
question from Matthew about the compatibility between ArcGIS and QGIS, and how this course is going to be, there's some relationship in this course.
Okay, so obviously this course is not gonna address QGIS. What's the compatibility is that actually in some senses, somewhat it's very comparable. What does that mean by comparable is that the capability wise, function wise, it's all comparable. But what's the difference is that the interfaces. It's a two different software. Basically, these two different software allows you to do the exactly same thing, but the button clicking and where is the name of the functions and what the name of the tools and so on and so forth, that's a lot different. So if you want to use the QGIS, kind of you have to learn the language that we use in this training, and you may want to rephrase and retranslate that language into the QGIS language. So the interface is I'm not 100% sure about what the compatibility, what's the definition of comparability, Matthew, but that's the two differences. Capacity is very comparable, but interface is very different. Is that the answer to your question?
Yeah, I think you said the compatibility with the function as far as um I'm basically here to be able to make maps and do some of the raster and vector analysis. So that seems to be something that I can translate, as you're saying, from ArcGIS over to QGIS.
Right.
Thank you.
Data also comparable. Though all those data that ArcGIS Pro used it, like later I'm gonna talk about this, like something called shapefile, geodatabase, raster files, all those vector, raster GIS files that ArcGIS creates and generates. QGIS can read and bring those files to the QGIS as well. So functionality data is very comparable and translatable, but the interface this is two different softwares. There's the interface is a lot different. Okay. All right. So Okay, going back to, okay, I have to catch up. Okay, going back to where I was. So hopefully everybody understand the purpose of those files. So presentation files are the one that I'm gonna use in the training session. The manual is, like a post training for your reference, okay? And if you guys go to the data folder, I put together data files that we're gonna use for training. So as you can see, there's 3 zip files, compressed file, day 1, day 2, day 3. So I want you guys to download this data and unzip it and make it available for the training session. I mean, this training is not just me talking. We're gonna have a lot of hands-on exercise together. That's why I ask you guys to bring the software with you. So to do that hands-on exercise, we need this data, okay? So let's make sure that you guys download this data and unzip it on your local computer, or I don't know, on your OneDrive or whatever, and then the cloud servers or whatever, and I want you guys to make sure to unzip it and make it available, okay? So that's the data and that's the materials that we're gonna use in this training session. We're good? Anybody has any question before we start training officially? We're good? Everybody good? All right, then let's get started. So the day 1, session 1 is the first session, right? I mean, this session where we're gonna talk about ArcGIS so-called map project, okay? The goal of this session is that I want to introduce how to put together GIS project, right? And using this software, what software called ArcGIS Pro, so I can sort of like slowly introduce kind of very basic things that you can do with the ArcGIS Pro, and then you can put together your GIS project, right? So that's the goal of this session. Tier, what, like a 10 study or something? Let me double check the first break that we're gonna take. So let's make sure everybody on the same page in terms of these schedules and everything. So let me take a look at it. So, okay, we're gonna take a break at 10:30. Okay, so we have about an hour. So let me move very quickly. Okay, so before we start the training, let's double check what okay, Roberto, if you go up to the chat box, there is a link. So that let me resend the link. This is the link that you can download all those data and material. Okay? Are you okay, Roberto? Okay. So before we started like a training session, why don't we just double check what the definition of GIS? What is a GIS? I mean, by understanding what GIS is, I mean, you can kind of like see what you can do and what exactly you guys are gonna, confront or envision. Okay, so There's so many different definitions. I mean, some academic definitions, some practical definition. There's a lot of definition about GIS. But if anybody asks me, how do you define the GIS? I want to define very sort of like a technical way. This is a very technical definition of GIS. Actually, GIS is deals with spatial features. What is a spatial feature? Spatial feature is something on the surface of Earth. Object, features, phenomenon, you name it, something on the surface of features. That's the spatial features. Then more technically, how can we make it some features as a spatial features? That means actually that has there's some features that has a XY coordinate so that we can pinpoint on the surface of Earth. Okay, so that's the spatial features. So anything that you can see on the surface of Earth, that's the spatial features. And the unique things of the GIS is that on the top of the spatial features, GIS offers the spatial feature with the attribute table. So a lot of times when I talk to the people thinks that, oh, GIS is the mapping software. I mean, that's partially true. A lot of people thinks that, oh yeah, GIS is about visualization, mapping, and things like that. Yeah, that's actually the spatial features aspect, right? We can visualize a lot of things on the surface of Earth with a nice graphics and nice representation. But actually, behind the scene, what allow us to make that nice visualization is this data attribute table. So unique features of GIS is that bring those attribute tables and some fancy visualization together. That's the GIS. And we can manage those multiple layers of spatial feature together. So that's the GIS. So I want you guys to think about this spatial features, attribute table, database, and multiple layer. I think that's the three keywords of GIS and what GIS can do. Okay. And if you want to do something with the GIS, obviously the first things that you may want to start your GIS software and you may want to do something with the software. And that something is so-called GIS project. You want to build the GIS projects, right, with the software. So, when you create a GIS project and you bring the data to that project and you can go from there and you can do whatever you want to do. Okay. So why don't we get started? Why don't we, mess with the software so that you can feel much tangible, right? So why don't we mess with the software? So if you go to your start menu and there's like ArcGIS, and ArcGIS Pro is the software that we're gonna use. Okay. In my case, actually, I have the shortcut here, but I mean, why don't I go with you guys? So why don't you guys click ArcGIS Pro and let's get started with the ArcGIS Pro. Yeah, my computer is a little slow. I don't know why, but let's get started, okay? Yeah, some of you guys asked me to email the zip file, but unfortunately, I'm not able to email you the zip file as an attachment because that file is like huge. I don't think, I can make attachments of the file. That file is like a really large file. So you cannot go through via email. Okay, so that's why I share the link with you, and I emailed you out the link. So please download the data from the link. Okay. All right. So my software started, and I have a lot of things. I have a lot of things here, but if you have not used the GIS, you do not see anything here, but that's not a big deal. My point is here. That's how you're gonna start your GIS project, okay? Particularly, what we're gonna do is that we're gonna start map project. I mean, you can start global scene and local scene project, but those projects is not something that I'm gonna address in this training session. Okay, those two are for the three-dimensional GIS. Some three-dimensional GIS is not one of the topic in this training session, so I'm not gonna use this. But many times, like if I say I'm using GIS, that means 95% I'm using map project. Okay, there's two different ways that you can start your map project. One is with this map project option, or start without template. Basically, they are same things, but I want you to understand something that's gonna happen behind the scene. Okay, so for example, if you try to start your map project with this map option, GIS will ask you a couple of questions. The first question is very simple. What's the name of the project? Right? So you can just give it any name. The second question is that actually, where do you want to save your map project, right? So you can think of this way. So, you started a Microsoft Word software, but typically in the Microsoft Word, you're gonna save your Word file after you typed a lot of things that you want to type in, right? And then you're gonna save it. But here, what GIS asks you is that, hey, why don't you provide me the name of the file, and why don't you tell me where you want to save up front, right? Then GIS will do something for you. That's these buttons, okay? And then that's how you're gonna be able to start your project with this button right there. Another way to start is this. This is the way that I described, a very similar way that I described like a Microsoft Word. If you go with the start without the template option, that then means, I'm not gonna worry about the file name. I'm not gonna worry about what I'm gonna save these things. I'm gonna take care of that business later, right? So that's the two different options, okay? So either way is fine, right? And why don't I just to give you an example? So why don't we why don't we start with this map project option? I mean, either way is okay, but why don't we start with this? So let me name file name. Why don't I name SCAG training SCAG? Why don't I say day one? And why don't I save this in my, let's say, local computer? Why don't I save it in my temp folder? Let me just name, I'm sorry. Just select this temp folder. That's what I'm gonna save. Okay? And click OK. So name and the path of this project, you set it up upfront. Then GIS will start. So that's how you guys are gonna start your project. And like Google Maps, it's a lot, you know, kind of a, for now, it's a lot similar to the Google map, and you can see that this so-called base map, nice reference map there, and you can start your project. Okay, and if I explain to you one more things, and if I show you my, you don't have to do this, but let me demonstrate it. And if I show you my map project file that I just created it, actually, see that's all something else. Let me get rid of this, not this one, but this one. See, if you remember what I did, actually I saved my file under this temp folder, but oddly, as you can see in your my file explorer, what I saved is not the file, but the folder, right? And if you go to I mean, not you, but if I demonstrated it, if I go into that folder, then you will see something called APRX file. I named SCAG day 1 APRX file. That's the project file. Let me explain this a little later, but that's what I actually saved. And as you can see, there is something more created. That happened behind the scene. Whenever you save your GIS project, GIS created these files. Actually, that GDB file is something called geodatabase. It's like a database, how can I say, data container. GIS creates as a default automatically. Okay, I want you guys to be aware of it. Then what's that? GDB files. Is that GDB file is something called workspace. Workspace mean the folders or data containers that you're gonna use primarily for that project. Okay, so whole point that I wanna make here is that when you save, when you created it, when you save the project file, GIS automatically capture the location of this project file and use that path or folder as your something called workspace. I mean, you don't have to worry about this for now, okay? But I want you guys kind of like remember that terminology, this jargon called workspace. Workspace is nothing but sort of like a default folder GIS is gonna use, this project file is gonna use. Then see, that's why GIS offer this option. Think about it. I mean, you want to open the GIS, you want to do just very quick things like, you know, just check a data, for example. You don't want to create anything, you don't want to save anything, just you want to open the GIS file and just double check a couple of things and you want to close the GIS. In that case, you don't want to create a new data container, you don't want to create a new, you know, project file, you don't want to save any work, no, nothing. Then you can simply go with this option, start without the template option. Then GIS not gonna create an APRX file, GIS not gonna create a workspace or geodatabase, no, nothing. So I want you guys choose two options wisely, right? Map option or start without the template option, so that you can, you know, choose the option that fits best with what you want to do. Okay, so either way is okay. Okay, so if I demonstrate it, if I start without the template option, no, I have to start. Okay, see, if I start without template option, nothing's gonna shows up. Then all you want to do is go to this under the insert tab, go to the new map, add new map. Then you can go to the scene that what exactly we saw earlier, right? So that's pretty much same thing before that we saw. So either way is okay, right? So I want you guys to choose whatever that you wanna choose. Okay, so let me open that file, that SCAG day 1 file. So why don't we start from there? Okay. So if I briefly go over this is the so-called map project. This is the interface that allows you guys to do whatever you want to do with the GIS. Everything, mapping, data editing, data analysis, creating a report, you name it. I mean, everything, almost everything that you want to do with the GIS, you can do with this interface and this map view. I mean, typically, whenever I say that, oh, I'm using GIS, that means 99% I'm using this map view. Okay. And quick sort of like overview of this interface is that, and that's a lot of tabs called ribbon tabs at there. So we can pull out a bunch of different tools and functions. Okay. And also under each ribbon tab, you see the sections, group of tools. So for example, under this Windows tool groups, for example, there is a bunch of tool buttons. Okay, so you can, by choosing those tools, you can do the GIS works that you want to work on. Okay, and left-hand side says content. That's a table of contents. It shows the list of data that you're gonna use in this project. For now, we don't have any data, but we will soon add the data here, and we're gonna play with it. Okay, and this is the so-called map view, and as you can see, there's like the map, sort of like a reference maps there. This reference map is called base map, like a Google Maps, and you can switch Google Maps from this kind of map to the like aerial satellite imagery views and so on and so forth, right? So GIS offer same thing and actually a lot more. So if you go to the, for example, under the maps ribbon tabs, and here you see the base map, you can choose any of these base map that GIS offers. So, the purpose of this base map is that GIS does not want you guys to have a blank canvas, right? And by having this map, you can have some orientation, geographical orientation, and also nice looking background map. So you can choose whatever base map from here that you want, then you can have, much more interesting, the background, right? Only things that I want to point at this moment is that this data, the base map data, does not come with your software. In other words, this data that you see is stored in ArcGIS server that comes from a server through your internet connection. So in the case that your internet connection is not so strong, this base map will slow you down. So I want you guys to be aware of it. This data, the base map data, does not comes with the software, does not in your hard drive. This data comes from the server. Okay. And why don't we add some data and start building our project? Okay, so here, if you want to add the GIS data to your project now, what you want to do is you want to click add data here, and in this bottom, you may want to navigate to the folders that you want, folders that has the data that you want to add, right? So you can do that, but if you want to do this, and every single time that you want to add data, you have to navigate to the folder, click and navigate to the folder. So that's a little sort of like a burdensome. So one way GIS help you to expedite adding the data is something called add a folder. So for example, if you go to this insert tab at the top, and there is add folder tools. If you click it, this interface does not ask you to add data. Instead, it asks you connect folder that has data. So for example, I want to connect my data folder. In your case, you may want to link the folder that you unzipped it, right? Day one folder, not a zip file, but unzipped folder. I want you guys to find that folder and link here. So in my case, my data is in my research folder, GIS training folder, and data, and day one, that's the folder that I want to link to my GIS project. Okay, so I want you guys navigate to the folder, like a day one folder, for example, that you guys unzipped earlier. And then you guys are gonna click OK. In the case, guys, that you navigate to the folder that you're supposed to find that day one folder, but if you don't see day one folder here, you may want to click this refresh button. Somehow, some way, GIS does not automatically refresh any folder change or data change after you initiated a GIS software. It does not automatically refresh. So this is like a manual refresh you're gonna superimpose, okay? Then you will see the day one folder. Everybody found the day one folder? Good. Yes. We're good. All right. Then all you want to do is click OK, and nothing's gonna happen. That's totally normal. Okay. Nothing's gonna happen, but that's fine. So if you linked your folder, data folder into your GIS project, it is time for us to add GIS data into your project. So for that, we want to go to this map tab, and we want to go back to this add data button. Okay, then you don't have to navigate, or you don't have to find the folder that has the data. All you want to do is to click here under the folder, then you will see that folder that you linked right there. So that will be always there. You don't have to worry about, explore your folder and navigate to that complicated path. So that's right there. You can access to the folder right there under the folders interface right there, right? So this is a one-time things. If you linked folder to your project one time, you can quickly, as a shortcut, right, detour it to the folder that you want to add the data from, right? And then I want you guys to go to the session 1. Then you will see these 4 files, 4 shape files. Everybody see it? Bike routes, community, county boundary, library, and parks. That's the GIS data that you want to play with in the GIS project. So I want you guys add all those 4 files. And if you click the first one and holding your shift key on your keyboard, and if you select the last one, you can select them all in a one shot. And if you click OK, you can add all 4 files into your GIS project one shot. Then GIS will add data to your project and zoom to the areas of that files. Everybody here? We're good? Everybody see what I see? Please. Okay, thank you. Thank you.
Hi, Doe. If my
Yeah.
park data isn't showing up, is it just maybe like a color thing, or did I
Oh,
miss a
okay.
step?
Okay, that's a good question, Jessica. And let me address that part. Okay, so yeah, if you have those 4 layers, I want you. That's something that I want to address next. So I want you to take a look at this table of contents. So that's the 4 files you added to the project. Terminology that I want to use here is that before you add the GIS data to your GIS software, I want to call GIS files. Like as you saw earlier here, you have 4 GIS files, right, in the session 1 folder. But as soon as that you add that GIS file to your GIS project, I want to call it layer. So you see these 4 layers. I believe Jessica's case is that the park layer is underneath of the county boundary, like something like this. What does that mean is that county boundary covers park layers so that you cannot see park layer underneath of county boundary layers. Am I correct, Jessica?
Yes.
See, now, if you remember what I mentioned earlier, in the definition of GIS, I mentioned GIS is something that handles multiple layers, right? This is the examples of multiple layers. Now, it's really seamlessly automatically done. We can overlay those 4 layers on the top of each other automatically, nicely, right? So that's the power of GIS. You may not realize this, but actually bring those layers onto the right location of the surface, that requires a lot of technology. That's a GIS power. We can, I mean, GIS make it this kind of like a overlay, really seamlessly, easily, right? So that we can see those 4 layers together. So you have control on those layers. So for example, you can turn on and off the layer one by one really quickly, right? So by clicking that checkbox, you can turn on and turn off each layer. As I demonstrate, also, I can move around this layer. If I drag and bring up the park layer on the top of the county layer, now I can see the park layer, right? So you can move the layers. So those of you guys familiar with, I don't know, AutoCAD or Adobe Illustrator and things like that, you may understand the concept of layer, right? So I'm talking about the paper layer, a paper on top of another paper. That's exactly this layer concept. So you have control on each layers, right? Everybody see what I'm doing, right? You have control. So turn on, turn off, move around the layer, things like that, right? It's very easy to do. I mean, that's the GIS technology, okay? And if you take a look at table of contents here, there's a lot of buttons there, right? I mean, you don't have to worry about this for now. It's very intuitive. I have explanation on one of my PowerPoint slide, what each actually buttons, allowed you to do so. I mean, you can take a look at it, but you don't have to worry about it. I mean, this is the far left one, like a drawing order one. That's the one that's primarily I'm gonna use it. And so if at this moment, one more sort of like a table of contents functions that you may want to be aware of it is that if you click the next one, which is the list by data structure, it'll tell you the location, the folder of each data layer. In this case, it's all those data that the layers that we grab is stored in this particular folder. So this data source interface will give you the location folders of the data layers. Okay, let's understand that much, and rest of them let me explain as the training session goes on. Okay, and next topic is that sort of navigation, map navigation. You can navigate the map exactly same as the Google Maps. Here, if you take a look at it, here, the navigate tool groups, there are some options of navigation. You can zoom in incrementally, and you can zoom out incrementally. You can go back to the previous zoom levels and so on and so forth. So that is some functions and tools available, but primarily you can use your mouse wheel, like your mouse wheel, like exactly same way that you guys navigate the Google Maps. You can scroll your mouse wheel and you can zoom in, zoom out. And if you press your mouse wheel and move around, then you can pan your map. So the map navigation is really straightforward. And if you guys have used the Google Map once at least, that's exactly the same. Everybody see it? I mean, it's very straightforward. Let me turn off my base map so that I can go a little faster. Okay, so map navigation, zoom, zoom out. That's exactly the same as the Google Maps. And somewhat, right, similar to the Google Map, if you guys click on, let's say, if you see, let's say, restaurant on the Google Map, right? And then if you click on the restaurant, Google Map will pull out the information and data about the restaurants, right? Same thing, you can do it in GIS. If you click, for example, any entity there, let me click, for example, this park, then GIS will open the attribute table information. It will tell you the name of the park, for example, what types of park is that, and that actually basic information about that park you can pull out and quickly take a look at it. Actually, this is the attribute table that I mentioned earlier. I mean, this is how we built this database, and this database attached to that particular geometry entity. So whenever we click it, and we can pull out this information of that particular entity. So for example, if I click on this bike route, it will tell me the name of the city, that bike route belong to, county and class, and plan, adopt the years and dates, and all those information that built up with that geometry, we can pull it out quickly, right? So, I mean, if you are familiar with Google Map, I mean, it's a lot similar to the Google Map, right? And similarly, we can take advantage of, for example, a measure tool. So you see this ruler shape icon under the maps and inquiry tool groups, and there's a measure tools. This is like measuring, for example, distance. You may want to set up your unit first, for example, Mars. Oh, I want to measure the distance between this library and this park, for example. That's 2.13 Mars, right? So it's a kind of a quick and dirty measurement, but if you click any entity and drag in and click it, and you can measure the distance between those two entities, right? So it's a GIS, like a Google Map. I mean, maybe you must have experience to measure distance in the Google Map. Similarly, here you can measure distance between the object. I mean, beyond the distance, you can measure actually area, something else. For example, oh, I'm just curious how many acres of this park is. Then you can quickly select acres option and the area options, and then select the acre as your unit. And if you just click, it's a kind of quick and dirty, but click, click, click. And if you draw the polygon, then GIS will tell you, oh, that's like almost 19 acres, right? So things like that. So what you can do with the Google Maps and you can do with the GIS, actually, Google Map actually stores a few fundamental functions of GIS, and they built their own survey system. So what Google Map offers, pretty much, GIS can offer as well, right? So that's a quick location measure tools, right? And similarly, the most common things that you do with the Google Map is finding the address, isn't it? Right? Oh, this is my friend's address. If you type the address, and Google Maps will drop the push pin at the location. That's exactly the same thing that you can do with the GIS. So if you click this locate button, you can type the address here. That's my school address, Carpoli Pomona address. If I type in, and bam, GIS will drop the point here, right? And the fun things about GIS is that you can actually preserve this location. I don't think you can preserve the address location in the Google map, but in the GIS, you can preserve this location. For example, I want to drop the graphics here. So if I right click on the address, if I select, for example, add the graphics option, then I drop the graphics. So I preserve this location so that I can find another location. For example, this is my home address. So, okay, it's my home. And you can see now the relation between my home and my work, right? So the California Pomona location is preserved right there, and I can drop to another location. And the same thing, I can preserve my home address, and you will see much clearly, hey, that's my home, that's my work, right? So you can have multiple address plug it in, and you can preserve the location, okay? So that's something you can do a little more with the GIS in comparison to the Google Maps. Let me delete those. Let me delete those locations. Okay, so and I believe Google Map offers the same thing. If you have like XY coordinates nowadays, GPS is very popular, and a lot of people collected the data with the GPS. And you guys are familiar with the GPS lat and long system. And if you click this go to XY button, and the windows lat and long windows will pop up bottom here. And if you type any X and Y coordinates, then you will zoom in to the XY coordinate. I don't have like XY coordinates that I in my mind right now, so I'm not gonna type in any XY coordinates here. But if you have any XY coordinates, if you don't want to find the location, you can type in here. Then GIS will do the same thing, drop the pin, and you can pinpoint it out XY location of the XY coordinates. Okay, so that's available there as well. So yada yada yada, and let's pretend that you did some work on the GIS, and you want to save this GIS work, GIS project file. Okay, for example, oh, I've done today's work. Let me save my work right now, and then let me go home, and tomorrow morning I'll come back to the work, and let me continue the works and I left behind, right? So I want to save the works that I've done so far. Then all you want to do is click this save project button, or Control S, the worldwide saving something shortcut also works here. All you want to do is click save button, save the project file, then you save your work, right? And my project file is SCAG _day 1. So that's work that I'm done, and I want to save my work. I saved it, and I close my GIS. So I'm done with today's work, right? Then let's pretend that, oh, next day I come to my work. Let me continue the GIS work I did yesterday. Then all you want to do is that, obviously you can open GIS, right? Has some also my computer is slow, and I have, I guess, a lot of people joining my Zoom, so I think that makes it even slower. But it's not worry about it. So just give it a second. So when your GIS software started again, you must be able to see the project file that you saved at the top. I mean, these are all project file I worked in the past, but pretty much the project file that you saved, you can see here, right? So you click here and open this project file, then you can go back to where you left. Right? So as you can see, you can go back to where you left, right? Similarly, if you find this APRX file on your File Explorer, just double click this APRX file, then GIS will open the project file for you again. So either way is okay. You can start your software first and find the APRX file and go from there, or find the APRX file in your File Explorer and double click it, and then GIS will open exactly the same thing. Okay, so that's the how you gonna start your GIS project, how you're gonna be able to save your work, and how to compare and compose your GIS project. Okay, and one last things before we take a break is that this APRX file or project file is for your own purposes. In other words, you're not gonna, it is not a good idea for you to share the APRX file. Okay, so for example, you working on the one GIS project with your colleague, and you did this work on your computer and you saved the APRX file. And they say, I have to pass my GIS project to my colleagues. So why don't I email APRX file to my colleague? So if you email the APRX file, and if your colleagues double click the APRX file on his or her computer, then your colleagues not going to be able to see what you see on your computer. The reason why is that APRX file does not store or save actual data file. Only APRX file store is that this path. APRX files save this path, not the actual data file. So when you open APRX file, what GIS does is that go to this folder and find this data file from there and try to open that data file in that folder. So in other words, unless your colleague has exactly same folder like this and exactly same data file in the same name, that APRX file is not gonna work at your colleague's end. Everybody clear? Everybody understand my point? So, yeah, Joanne?
Can you have all this data file on a shared drive where everyone has the same access to and make it work, or?
Yeah, so if you have one shared drive and everybody store all this data file in the shared folder, and everybody pull out the data from the shared folder, no, not everybody, but APRX file, pull out the file from the shared folder, then may work. But see, this is my OneDrive cloud server, right? For example, this is my my cloud server. What I'm saying is that the path to that shared folder should be exactly same. This text value, right? This text should be exactly same. GIS does not care. Unfortunately, GIS does not care. This is the shared folder or is a folder in the somebody's local computer. All GIS care or all GIS try to find is that, hey, that path right there. Okay, so you got to be a little careful with the sharing your project with a colleague. So with this little complexity, GIS offers something called project package file. If you create a project package file, what project package file does is that compile all those data in the project and path and everything, and then zip it up into the one file and make it, comprehensive package file. So if you email this package file to your colleagues, that will do everything. Okay, so my recommendation is that if you plan to share the project with your colleague, creating a package file will be a good alternative. Obviously, creating a one shared folder in a cloud server and put everything there and pulling the data from there, that may work. But as I said, there is some complexity in how that shared folder each local computer will read. Depending on that APRX file may work or may not. But if you put together a package file, you don't have to worry about anything like that, okay? So, for example, I want to share this project with my colleague. Then, why don't I create a package file? So, if I click shared tabs up there, and if I click project here, then it will create a project package file. In this interface, you have kind of two options. It says upload packaging to the online account, and another is save package to file. Either way is okay, but my recommendation typically is save the package file, save the package to file. The first option, this one, if you created a package file, this package file will go to your ArcGIS online account. But in order to take advantage of this option, your local software should have a really seamless link to your ArcGIS online account. Then this works okay. But otherwise, let's say you using, I don't know, your city's account, or you share the account, multiple users share the one account and things like that, then there's a little complexity. So my recommendation is to go with the second option, which let you guys save the package file on your local computer. Then you can treat that package file as exactly the same computer file, any other computer file, right? So you can email it, and you can copy and paste. You can do whatever you want to do. So if I were you, I may want to save the file under my local computer. So let me save this package file to under my local computer. For example, let's say, why don't I save under my downloads folder? Let me save here Orange County Day 1. Then before you put together a package file, GIS gives you an option to choose any problematic issues. So if you click this Analyze button at the very bottom left corner, GIS will analyze some ongoing issues or errors, and it will generate errors here if there is any. right now we don't have any errors. It says no error or warning. Then all you want to do is click the package file, package button and say yes. Then GIS will put together package file. Yeah, my computer is somewhat little slow, so just let's be patient. Okay, so when package file successfully created, the GIS will give you a message, yeah, your green check mark with the successful creation. And if you take a look at that file, so in my case, I mean, let me show you that file and with the File Explorer. So OC underscore day one PPKX file. That's the package file that I created it. Then, as you can see, this is like almost like a 4.5 megabyte file, which is a very large file because it contains all those data together. So this is the file that you can send you to your colleague. If you emails this file to your colleague, and when your colleague receives this email, all he or she want to do is that double click this file in the File Explorer, then that will open exactly same project file. So let me, I know it's 1 minute over to the break, but let me demonstrate one thing and quickly, and let's take a break. So let's pretend I received this email attachment file, then all I want to do is just double click it. Then my GIS will open and show what my colleague put together on my computer. Okay? Everybody clear? So the point is that APRX file, which is a GIS project file, is for your own purposes when you manage your GIS project by yourself. In the case that you want to share your GIS project with somebody else, I strongly recommend for you to create a package file and share the package file. Right? So as you can see, my GIS opens and it's a little slow, and it will show where I put together what I put together, what my colleague put together, right? All right, so that's what I have for the first session. Why don't we take a break now, like a 15-minute break, but I mean, it's at 10:33, so 12-minute break. I'll meet you guys back in 10:45. Okay? Everybody back? Can we go back? All right. Then the second session of today is understanding GIS data. It's not a lot about the software, but I like to make sure that you guys have a really good understanding of the data that you deal with. Actually, the pros of GIS is that there's a large amount of data is available. Data is really rich and abundant, and all those public sector from the national government to the local governments that created the GIS data and manage the data and make it available. And then those of you guys is GIS data users, but at the same time, maybe GIS data creators, right? And a lot of data is available, and almost, in my case, there's like I have not actually struggled with the data. I mean, a lot of data is available, and one of the example is this SCAG regional database platform content library. And if you just Google the SCAG content library, and you can find out this long list of data, and you can download the data from here. So for example, that if you want to download this GIS data, you click it, and you simply click the download button, and you can download it. I mean, also the good thing is that nowadays, I mean, Edge did a really good job and standardize these data downloads interfaces, so you can quickly download it with the data, by finding any types of data set that you look for. And then Orange County as well offers large GIS data bases, right? So I believe the interface here is fairly similar, right? So if you click any data, and as I demonstrate here, the interface is a lot similar, so you can download it. And this is not the one that actually, so see, it's exactly the same interfaces, right? So you can download it. So pretty much whenever you need data, I mean, you can explore, and you can Google, and you can find the data, and really large amount of data is available. Obviously, there's also data gaps, right? I mean, the data that created by national level is not detailed enough for the local planners to use, and so on and so forth. There's the data gaps there, but I mean, the bottom line is that large amount of data is available. I don't know how many of you guys, for example, have used SCAG's streetlight data. I mean, SCAG offers streetlight data, which is like a real-time pedestrian, not only the pedestrian, but the real-time traffic volume data based on cell phone signals. So you can download it for free, and SCAG actually licensed subscribe to the data, and all those jurisdiction in the SCAG regions can use that data, and so on and so forth. So that's the sort of examples of the data, right? So the point here is that data is available, and then you may want to have really good understanding of GIS data so that you can take advantage of that data available, right? So the goal of this session is that I want you guys kind of have a really clear understanding of data and types of data and GIS data, so that you can take advantage of those available data out there, okay? And broadly, very broadly, there's a lot of different types of GIS data. I mean, you name it. I mean, let's say, for example, I don't know, facility management department that we usually generate AutoCAD file, for example. I mean, GIS has capability to read that AutoCAD file. And I don't have a GIS license. I'm kind of very familiar with let's say Google Earth. I'm using the Google Earth, and the Google Earth file is a KML, KMZ file, for example. Yeah, GIS can handle that file. So there's a lot of different types of file GIS can read and GIS can process, but primarily GIS file, when we call it GIS file, then there's typically we call shapefile. That's the very well-known, so like a legacy GIS vector file. So, for example, whenever you guys go to any GIS data sources, and when you try to download GIS data, for example, then it typically asks you to download shapefile, so-called shapefile. CSV file, right? Table file, comma, delineate the table file, and KML file, as I said, this is the Google Earth file and shapefile. And GeoJSON is the sort of like open source GIS format, things like that. So whenever you guys see something called shapefile, that means, oh, that's a GIS file. Oh, I'm sorry. That's the GIS file that we're talking about. But it's a kind of like a based on vector file, vector system. Let me explain what the vector is. But I mean, shapefile is like yeah, the GIS file that's invented by ArcGIS, as a very original GIS file for the very early, the first GIS software. So that's the legacy sort of industry standard GIS file we call shapefile. And GIS also can read some database file, which is a table file, DBF database file. So that's a lot similar to like a Excel spreadsheet or CSV file, so like a standalone table file, okay? And there's a raster file. Another types of the file is the raster file. I mean, we're gonna play with the raster file the day 3 on Friday, on Thursday, I'm sorry, Thursday. So that's the, so we call grid file. This is a pixel cell based file. So let me explain what exactly is this in little detail later, but I want you guys to be aware of this terminology, grid file or raster file, okay? Another file type is so-called geodatabase file. Actually, geodatabase is not a file. It's a database container. It's a lot more than just simple file. It's a kind of shame on me saying geodatabase is a data file. It's not a data file. It's a database system called relational database system. Anybody familiar with like Microsoft Access or Oracle and things like that? Anybody? No? Have you anybody heard of something called relational database? No. So geodatabase is like a latest edition that actually allow us to make our database management much easier and much more efficient. So for now, why don't you just think of this is a database sort of like a container. We can contain, we can store a lot of data layer or data file in that container. Earlier example is that, you know, when we save the APRX file, as I show you, GIS as a default automatically creates something called GDB file. That's a geodatabase file. So, you know, regardless of you understand or recognize or not, GIS, you know, automatically as a default created something called geodatabase file. And right, okay. Have you guys thought about, everybody know the company called eBay, for example, right? Yeah, you know the company called eBay. Have you guys thought about the database that eBay manages? How complicated and how complex that database is? I mean, for example, if I want to sell this item, my, you know, earbuds, if I want to sell this item on eBay, right, there must be information about me, seller, right? And then there must be database for the item, the price, colors, size, or whatever, right? Then when bidding started, then there must be the database for the bidders, let's say 100 bidders bid on my items that I try to sell on eBay, then there's like a bidders database. Their, I don't know, their ID, their address, their bidding price, or whatever, all those information. And when bidding is end, the winners database should be created. And shipping and handling database should be created. Payment database should be created. See, everybody understand how complex this database is with one item on the eBay? How many different items on eBay? Billions, millions. Then everybody can see how complex eBay database is. Database systems that allows the company like eBay manage your database, efficiently, so that they can pull out data, piece of data anytime they want, easily, efficiently. Also managing this crazy database, crazy large database efficiently. The systems that allows the company like eBay to do so is relational database. So they use maybe Oracle, software called Oracle. Here, geodatabase is the GIS versions of relational database. As database structure of GIS database structures get complicated and become a much larger and larger and larger, a lot of institute and organization want to manage their GIS database very efficiently. And they want to organize them very well. Like examples that I gave you, like eBay examples that I gave you. That's why this database type invented it called geodatabase. That you can do a lot of things. But for now, I'm not going to be able to go really in depth in the geodatabase that shows the capacity of the geodatabase. Why don't we think geodatabase is the database container? Okay, let's just do that much. And if I explain this data type, data file one by one, I mean, fundamentally capture spatial features, once again, according to the GIS definition that I define, GIS is the system that capture and manage the spatial feature. And the question is that how we want to capture these spatial features. GIS offer fundamentally two different broad categories on how to capture spatial feature. One is the vector approaches, the other is raster approaches. Vector approaches is GIS want to capture spatial features or phenomenon with the three different geometry types: point, line, polygon. There's a few more additional geometry types, but let's not worry about it. The fundamentally also shapefile approaches, the sort of like legacy approach is capturing spatial features with the three different geometry types: point, line, polygon. Right? So it sounds very simple. Can we capture everything in the world with those three simple geometry? GIS response is yes, we can do, right? For example, if you want to express the city in the worldwide at the global level, we may want to express city with a point. But if we want to express or capture the city at the county level, for example, then we can capture the city's boundaries and express city with a polygon, for example. That's the vectors approaches, okay? Rasters is on the other way, capture everything with the pixels or cells, like a very popular raster file, and the raster files that you may familiar with is the JPEG file. If you take a picture with your cell phone, that will create a JPEG file, which is the all pixel based. Each pixel saved each color, right? Actually, not color. Each pixel saved actually one numerical value, quantitative number. That number represented each color, so that when we open the JPEG file, we can see the colors. But the whole idea is that it stores color, the numbers. Similarly, raster files, in GIS stores number in each cells. So that's the two different approaches. Obviously, two different approaches has two different approaches. Vector and raster has their own pros and cons. But let me briefly explain that a little later. But that's the important thing is that here are two different approaches. Raster file, as I said, is all cell based, and as I said, it stores one number in one cells. Okay, then numbers can be very discrete number, categorical number, or it can be continuous numerical numbers. So, for example, if you want to express land use map with this pixel-based raster data, that's doable, because you can save each land use classification numerical value in each cells. Then that cell will represent the land use type. So, for example, I can store 1, 2, 3, 1 mean residential, 2 mean commercial, 3 mean industrial. Then we can express, land use map like a JPEG file. So we can express land use map whether it's raster data. Another good example is showing the continuous, changes on the surface of the Earth. So good example is elevation, right? So each number stored in these pixels or cells representing incremental change of elevation. So when we express this incremental change, raster is better. So I want you guys to think about this. Let's say temperature. If you guys take a look at morning forecast, they typically express the temperature change by, let's say, point. Oh, city of LA, it's gonna be 78 degree, and city of Pomona, it will be 80 degree, right? They pointed out the location of the city and they shows the temperature. But I'm just a little curious about, hey, what if the temperature in between LA and Pomona, right? But if we express with this incremental change with this all covered by cells, then we can show the temperature change without any gaps, right? Another example is like this elevation. I mean, those kind of GIS file that you may familiar with in terms of the elevation is a so-called topo line, right? Topographies or topo lines. The line shows the height or altitude of the location, but I mean, what's the drawback of the line? We don't know the elevation in between the line. But if we express the elevation with this raster this way, there's no gaps, right? So that's the advantage of raster files, raster approaches. Vector data, as I said, point, line, polygon. It's very simple, try to capture the features and object on the surface of Earth is very articulately. So, we can trace the buildings and properties and, roadway and everything, right? It's very articulated way. But, I mean, as I briefly mentioned about the raster, advantage of raster, I mean, obviously there's an advantage of rasters approaches, but, vectors approaches that we can articulately captures, that the objects on the surface of Earth. So one actually Yeah, so the question is that do you set the size of each cells? Yes, we need to define the size of cells for the rest of our. Joanne, why don't we keep this a question, and in day 3, we're gonna explore much further on the raster data, and we're gonna fully discuss about size of the cell. Okay, so that's the really good question, but we're gonna discuss on this in day 3. Okay, so yeah, actually resolution, right? How good this raster data is totally depends on the cell size. So that's about the resolution issues. Okay, and let me come back in day 3 and continue on the vector data. So for example, I mean, raster data has a great advantage, but I mean, an example that I want to give you is that when I was in the planning consulting firms, I had a sort of like a land use simulation types of outputs, and I expressed that land use simulation in the raster format, and I presented it to that finding in the public meeting. And one actually participant, attendee of the meeting, says that, oh, it looks like that area covers one of my property, and can you show me where my property is? So I pointed out, oh, that might be your property, and he says that, no, my property does not look like that, because I expressed his property with the pixels. So I explained, oh yeah, I understand this is not the not the way that exactly capturing your property. It's like just like a representation of with the cells, and I explained everything, but he didn't get it. He says, no, that's not my property. He just keeps saying, that's not my property. Right? So you see the point here. If you want to capture something on the surface of Earth exactly, precisely, accurately, you don't want to use the raster data. You may want to use the vector data, right? Obviously, if you want to build with somebody's property or property line, should be very articulated, very accurate. Otherwise, you guys are going to get sued, right? So in that application, vector is better than raster. Okay. And as I said, shapefile is the GIS data file that's kind of like stores vector geometry, either point, line, or polygon. Okay, so that's the sort of whenever you guys download it, as I showed earlier, whenever you guys try to download any data, and if you find anything says that shapefile, so for example, SCAG contents library says shapefile, that means you may want to understand this is the vector GIS file. Okay. Then point, line, polygon. Let's say if you take a look at the data that we used earlier today. Hold on, let me reopen my project file. So no, not this one. So if you take a look at data file that we used in the session 1, the earlier session, and if you go to the add data, obviously, if you add data in your GIS project, you can see this is a point, line, or polygon, right? So you can see the very clear distinction in the geometry. But even before you add data to your GIS, these icons will tell you what types of geometry stored in each shapefile. For example, this is line, polygon, point, polygon. Right? Line, point, line, polygon. So these icons will tell you what types of geometry, right? Point, line, polygon, what types of geometry stored in each shapefile, right? Without even adding the file in the GIS project. Then you may want to ask me the question, would it be possible for us to store, multiple geometry into the one shapefile? So for example, point and line together in the one shapefile, or line and polygon together in a one shapefile. Unfortunately, that's not possible. If I want to explain why not that's possible, I have to explain the concept called topology. It's not complicated, but I have to add explanation and explanation and explanation. So for the sake of time, I don't want to go that route. But the bottom line is that you're not gonna be able to mix multiple geometries into the one file. Okay, I want you guys to remember. So what's the important point here is that in the case that you created your own GIS data, you may want to think very carefully and make a decision on what kind of geometry that you want to choose to capture what you want to capture. Then you want to go with that geometry type that you selected up front. You're not going to be able to switch it. You're not going to be able to do anything after you created a file. So you have to think carefully the geometry types up front. Okay, so the bottom line is that you're not going to be able to mix multiple geometry into the one file. Okay. Another important point that I want you guys remember or understand, not remember, but understand is that the multi-file structure of shapefile. So for example, what does that mean is that if you take a look at, my session 1 folder, there's a 4 shapefiles, right? But if I show you that folder, the exactly same folder in the File Explorer, navigate to the folder, just give me a second. No, not here. Session 1 folder, right? You see how many different files? There's a 36 files. Here in the GIS, it only shows the 4 files, but here if I take a look at this file, File Explorer, there's a 36 files shows up. Bike route, a lot of different bike route files, right? So the bottom line is that those multiple files together, in this case, 9 files, actually this is just log file, so that's not even GIS files. So let's say in this case, 8 bike route files together make a 1 bike route shapefile. Okay, I want you to remember this. The reason why this is important is that, so for example, when you guys make a copy and paste of the GIS file, you need to copy and paste all those files together. If you miss the 1 file or 2, that means you're gonna lose very important information, or you're gonna mess with the GIS file. So what I'm saying is that out of those 8 files, there is the files that you must have, which is DBF, SHP, SHX. Those 3 files that you must have. If you missed one of the file, that means you ruined the file. You're not going to be able to open this file in your GIS software. This file, PRGen file, SBN, SBX, it is okay to miss. It's okay while you're losing very important information, but you can still open the file. So the point here is that GIS shapefile structure is a lot different from any other computer files, like let's say PowerPoint file or PDF file or Microsoft Word file, which is the one file representing one files that you see in the software. So you got to be super careful. Okay? I don't recommend at all for you guys to use File Explorer to copy and paste GIS file. So, for example, forget about this. You don't want to manage your GIS file with the File Explorer. Okay? Then what are you supposed to do? You guys gonna use something called catalog. You don't have to click this. I don't recommend it. Okay, but I mean the reason why GIS offer this catalog upfront is that catalog is the ArcGIS Pro versions of File Explorer. So whenever you want to make a copy and paste and move around the files and delete the files, whatever that you typically do with the File Explorer, you can do with the catalog. If you use the catalog, you don't have to handle that multiple files. If you copy one file and paste it, GIS will take care of grab all those multiple files together and make a copy and paste. So it's a lot easier, and also it's a lot error-proof, right? I mean, we're human beings, we often make a human error, right? But if you use the catalog, we can avoid, unexpected human error. So catalog is how I use it. I strongly recommend for you guys to use it. But I don't start catalog project. You don't have to do it because you can access catalog via your map project. So if I go back to my map project, and in the case that I want to manage the GIS files, I don't open the catalog project separately. Instead, I go to the View tab. And I use the catalog pane or catalog view. Catalog view, we created like a catalog project, but personally, my preference is a catalog pane. It's pretty much the same thing. But the reason why I prefer catalog pane is that if I open this catalog pane, I can manage, catalog and map project together. Even I can dock my catalog on my, GIS interface so that I can manage my GIS files along with my GIS project. So catalog pane or view, either one is okay, but I mean, that's my personal preference is the catalog pane, okay? Then here, like the way that you guys linked folder earlier in the session 1, you can, I already kind of link my folder so I can see the folder here, but also if you want to add another folder, you can right click and add folder connection so that you can connect your folder here, but mine is already there. So if I navigate to the folders of the session 1, as you can see, and as I demonstrate here, this is a lot similar to the File Explorer interface, right? So that, if I want to copy and paste, for example, this file, bike route file, right click, then you see the copy, cut, or delete, rename, all those like a File Explorer types of menu you can find. So I can copy here, click, and if I paste it in the session 2 folder, for example, let me show you my session 2 folder here in the File Explorer. And see, I don't have anything much in the session 2 folder right now, but if I copy and paste it the bike route to the session 2 folder, see, now I copy and paste, bike route shapefile to the session 2 folder. And if you take a look at it in the file explorer, those all multiple files came together. So it's error proof. You don't want to worry about this multiple file structure. So the reason why actually the software company offer something called catalog is that it'll help you guys to manage the GIS file. Once again, handling GIS file with the file explorer is not such a good idea. I strongly recommend for you guys to use the catalog. Okay. And why don't we take a peek of the rest of the file? See, this is this is not grid file, but it's an example of raster file. So if you take a look at the file under the session 2 folder, you see temp_PM. That T file, this is a sort of imagery file, but it's very, how can I say, comparable to the Agile grid file. So let's take a look at this file. So if you have this, obviously you can go add data, and you can add data using this add data button. But another advantage of a catalog is that we already opened the catalog and doc in my project. It's very handy. So all you want to do is click, drag and drop this file to your map, then GIS will add this file and open these files, okay? So all you want to do is just click, drag and drop it, okay? And my GIS is now working on, really slow. Right, so now, as you can see, I edited up this raster file. So that's the raster file, example raster file. So this is the sort of like a temperature of this area, any given summer afternoon temperature. So it goes from 80 degrees to the 67 degree. And if you zoom in, you will see the pixels. As I said, like everybody see the pixels, right? So it's a lot similar to the JPEG files that you guys are familiar with. And, this is the pixels and cells that we're talking about, right? So each pixel stores one value, the numerical value. That's the raster file. So if I click one cells, I think I can retrieve the temperature on that pixel is 71°.227 or whatever. So we can retrieve the temperature data stored in each pixel. So that's the sort of like examples of the raster data. So now you can see the sort of a dramatic contrast between vector data, like shapefiles, and raster data, right? So that's, I hope you guys have a little better understanding of the vectors, vector and rasters, okay? Good. All right, so next one is a little brief touch upon on geodatabase. As I explained earlier, geodatabase is actually database container in the relational database system, which means, simply we can create a geodatabase and we can dump a lot of data file in this container. Not only just dumping on the multiple files, but also we can kind of like connect them each other using something called relationship features. So if we build something called relationship features, we can intertwine all those data files together. I mean, that's how eBay can quickly pull out all those data. So I want you guys to think about this. Let's say if you have any complaint on eBay and you may want a phone call to the customer service, then the first question of that customer service persons ask you will be the, oh, what's the item number? Or what's your phone number? Or whatever that, some sort of like an ID numbers that recognize your case. If you give that numbers that customer service people type in, and then if that person pull out the entire data set, it comes, he or she can quickly pull out the entire data set. Not only about your personal information, but also about the information of all those items that you try to sell it, you want it, and all those history related to yourself. So that's actually something that makes that quick linkage of the databases possible is something called relationship class. So if you create a relationship relationship class under the geodatabase, you can interconnect all those data files in that geodatabase. That's the one advantage of the geodatabase. Another examples of the geodatabase advantage is something called topology class. So I want you to think about this. So it's called object-oriented database. I mean, that's the kind of database jargon, but an example is this. Let's say there's somebody's property like that, right? And we know urban blocks, right? So that's the urban block, that's an urban block. And somebody's property is there, right? Something like that. And that's the property here and there. And let's assume that you are about to create a street center line. So street center line typically goes like that, right? You want to draw the street center line, I mean, for example, something like that. I mean, if you created a geodatabase, and if you created a street center line, for example, something like this. One afternoon, you're dead tired and you lost your focus and you draw the street center line, something like this, which is the impossible in real world, right? In real world, there's no road that can go over somebody's property. So in order to avoid this situation in the geodatabase, you can create something called topology layer. Then when you make a mistake like that, GIS will give you a warning sign. Hey, dog, you are doing stupid things right now, right? These types of roads goes over somebody's property cannot exist. So it will give you a warning sign. Then we can avoid human error. That's another way, another examples of the, how geodatabase behaves. Okay, so it's a lot more than simple container. There's a lot of features, a lot of, how can I say, advantages that geodatabase has it. But unfortunately, I'm not able to go, over the details of all those advantages and how you can create a relationship class or how you can create a topology class. I mean, I'm not able to have time to do so, but I want you guys to be aware of that. There's a lot of features that makes your GIS database much more efficient or much more smartly behaves. That's the purpose of geodatabase, okay? And just little flavor of geodatabase that if I want to introduce, we can organize geodatabase much more kind of like hierarchical structures and much more, how can I say, organized way. So I want you to think about this. If you want to store GIS shapefile in the folder, obviously taking advantage of the folder and subfolder structure, you can build your you can store your GIS data file, something like this. Let's say, for example, see, this is a really good example. Orange County GIS portal, sort of like organized their database is something like this. So maybe in the boundary folder, there can be there are some files. Maybe even boundary folder can be can have the subfolders. Let's say county boundary, city boundary, or something like that, right? So basically, the point is that under the one broad category of the data folder, you can create a subfolder, and you can create another layers of the subfolder, and you can store the data shapefiles in that structure. Similarly, you can create that hierarchical structure in a geodatabase using the system called feature data set. So geodatabase is equivalent to this folder in the top hierarchy, and this feature data set is equivalent to this subfolder. Within the subfolder, we can create something called feature classes, which is the equivalent to this shapefile. Okay, so I want you guys to think of this hierarchical structure. So, for example, if you put together your database, GIS database for your cities, you may want to call it I don't know, city database. You can create a city geodatabase, and underneath of that, you can have, like, let's say, a transportation feature data set. So you can have roadway, sidewalk, public transit line, or whatever transportation data layer underneath of transportation feature data set. And you can have environmental feature data set, and you can have air quality, and I don't know, habitats, preservation, whatever environmental layer underneath of the environmental feature data set, so and so forth. No, actually you cannot open geodatabase in Microsoft Excel. Microsoft Excel actually is a totally different structure. Okay, so you are not if you're looking for something Microsoft product, something equivalent to the geodatabase, that's Microsoft Access. Okay, so geodatabase is a completely different structure. So if I show you the geodatabase, for example, in the File Explorer, I don't want you guys to get confused with Excel and geodatabase. So if I show you the default geodatabase created here earlier when I saved my project file, that's the geodatabase. If you take a peek inside of it, there's a crazy file structure there. Okay, there's no file that you can open with the Excel spreadsheet, right? Yeah, you can. I don't recommend it, but you can give it a try to open geodatabase with the Microsoft Access. Okay, but that's not actually MS Access is not an ideal software, because it's just, in terms of like a relational database, it's a comparable, but geodatabase has its own system that Microsoft Access cannot read, like a spatial features and so and so forth. So DBF, yeah, but I mean, yes, technically you can open the DBF file of the shapefile in Excel, but I don't want to recommend that because if you open that DBF file in the Excel, then you are kind of separating attribute table from the geometry. As I said earlier in the definition of GIS, GIS is a feature, spatial feature, which is geometry together with the attribute table. I mean, technically you can open the DBF file in Excel, but I don't recommend it. Why do you want to open the DBF in the Excel while you can do everything that you want to do in a GIS? Yes, you can, but I don't want to recommend it. Okay, it's a totally different animal. Okay.
Thank you, Professor Kim. I don't want to derail us, but I really appreciate that explanation, and
Right.
can chat with you separately about that. Thank you so much.
Comparable, but let's not do that. I mean, that's my answer. Okay, so the kind of like hands-on exercise that I want to do with you guys is that let's give it a shot to create our own geodatabase, and let's construct our geodatabase in a way that we want, rather than one that's default geodatabase GIS created for you, which is almost nothing. So how to create a geodatabase, and right click on the session 1 folder, for example, any folder that you want to create in a geodatabase, right? Okay, why don't I create it in a session 2 folder? It's a session 2. So why don't I right click on the folder that I want to create a geodatabase? And if you guys go to the new, and there's 2 geodatabase type there, file geodatabase and mobile geodatabase. I mean, you kind of see, mobile geodatabase for the some, cell phone apps and so on and so forth. Let's not worry about it. And I want to create a file geodatabase. So let me click a file geodatabase. Then GIS will create a quickly new file geodatabase, right? I mean, if you want to rename it, you can right click, go to the rename, and you can change the name, like whatever name that you want to give. Let's say OC day 1 or something, whatever name that you want to give for your geodatabase. You created a geodatabase, okay? And those of you guys who are familiar with the desktop ArcMap, and the difference is that you may not see something called personal geodatabase here. ArcGIS Pro does not read personal geodatabase anymore. So those of some of you, some of organization and institute and governments, that if you guys, in the process of the migration from the desktop GIS to the ArcGIS Pro, please move all those files in your personal geodatabase to the file geodatabase. Okay. Once again, personal geodatabase is not anymore readable with ArcGIS Pro. So if you stop using desktop GIS, you cannot open, or you cannot take a look at the file in the personal geodatabase. Okay, that's a tip for your migration. Anyway, so if you created a geodatabase like that, you can right click on the geodatabase and go to the new one more time. Then there's the sort of like object you can add to your geodatabase, right? So for example, I want to create a feature data set. And all you want to do is give it a name of the feature data set. Let's say, oh, my plan is this. Why don't I create a civic service feature data set? And my plan is that I want to move park and library under the civic service data feature data set, because library and park is, you know, is a types of the civic service. Okay. And coordinate system, this one. For here, all I want to say is that you need to pick one coordinate system, one consistent standardized coordinate system for this feature data set. Then every feature class or every layer underneath of this feature data set will share exactly the same coordinate system. Coordinate system, once again, it's a $1 million question. To me, that's one of the most important topic. A lot of things that GIS does behind the scene controlled by coordinate system. But it is really hard for me to explain what coordinate system and how it works in a short amount of time. It's almost impossible. In my actually not even intro GIS class, in my intermediate GIS class, I spent about a couple of sessions. One session for like a 5-hour sessions to cover coordinate system only. So I'm not able to explain every single details of a coordinate system, but here you may want to choose the one coordinate system. So let me choose anything. So here, why don't I select this library layer, any layer here. If you click here, why don't you select any layers here? Then it says net 1983 state plane, California 5/5/0405, right? NAD, NAD stands for North American Datum, which measured in 1983. The name of the coordinate system in this case is a state plane, California Zone 5, not V. It's like Roman, no, the Greek, is it Greek numbers, V. So let's go with this, okay? Let me briefly explain how coordinate system works if I have time, because I don't think I have time because I already, should wrap it up, the session. So let's not worry about this. Let's go choose the one and just run and see how GIS creates this feature data set. So now feature data set is created. So if I go back to my geo database, I was able to create a civic service feature data set. Then underneath of this civic service feature data set, I want to bring this park and library layers, right? Like a feature class. So right click on the civic service. In this case, I want to just simply import, right? Import feature classes. Then if I select library and park underneath of this feature data set, then if I run, GIS is gonna take time. Yeah, so my import is successfully done. And if I take a look at now, underneath of this feature data set, I have 2 feature classes, right? So that you can keep building your geo database like this kind of hierarchical structure. Good. So you can keep adding the layers to, or layer or shapefile to the feature as your feature classes underneath our feature data set or directly into the geodatabase. So you can keep building the geodatabase this way. So if you want to make a one kind of comprehensive master container that contain all those GIS data, and you can take advantage of the geodatabase. Okay. Any question? So that's actually pretty much it for what I have for today. So if anybody has any question, I'll be happy to answer. Okay, so attribute table of a shapefile, then download it into the Excel. Yes, yes. Between Excel and GIS, it's like bi-directionally very straightforward. For example, if I want to Excel file to my GIS, I can simply go to the add data and let me find it out any Excel files. Let's say, see, this is the Excel file. So let me open this Excel file. Come on, computer, speeds up. My computer is, I'm really sorry, but my computer is really slow. And I think this Zoom meetings eats up a lot of my memories. That's why. But anyway, so okay. So that's the Excel spreadsheet, right? One sheet, and I can simply open and here I can take a look at Excel spreadsheet in my GIS just like this. As you can see, you can open the Excel spreadsheet in the GIS. And Matthew's question is the other way around. So as you cannot do anything in the file in the geodatabase, but shapefile, as I show you, shapefile has the attribute table component, like a Tom clarify in the chat box. There is attribute data portion of attribute data portion of a shapefile, which you can find. Let me show you. For example, do you see this so-called DBFR? That's the attribute table of the shapefile. You can open this file with Excel. I mean, Excel kind of does not allow me open this by double clicking, but if I open the Excel, and if I open any file, if you change this file to the DBF file right here, DBase file, that's the DBF file. So if I navigate to the folder that I have that file, my shapefile, yeah, you can open like this. But here, see, I show you, you can do it, okay? But yeah, technically you can do that, but I don't recommend it. The reason why I don't recommend it is that if you open it up, DBF file that associate with your shapefile in the Excel separately, minor things here and there, you do this, that you can save, you can update the file, but how GIS and Excel read that DBS file is different. So if you make a sort of like a significant changes or some things on the Excel, opening the DBF file in Excel side, then it's gonna mess up your file. So your file may be corrupted. I don't recommend it. So if you want to work on any sort of Excel spreadsheet types of work on the GIS file, GIS attribute table, you can do in a GIS. Tomorrow, we're going to go over that a lot. But in the case that you really, really, really want to open that file in the Excel, even if I say strongly not recommended it, you can do it, and my recommendation is this. I want you export out that table as an independent table, stand-alone table. If you right-click on any layers, and if you go to the data and go to the export table, then you can export out that DBF file as an independent DBF file, which is separate from your shapefile. Then you may want to work on. Okay, so there's a two different structure. Actually, it's a DBF file of GIS attribute table looks like a spreadsheet, but it's not a spreadsheet. It's a table. Table and spreadsheet are different. Okay, everybody. Do you know my point? Table and spreadsheet is a different. So, for example, whenever you guys open the Excel file, I don't know how you guys are using the Excel file. So the one example is that if I open the any Excel files, let me open it up, a small Excel file. For example, this Excel file. This is the spreadsheet. It's not a table. How GIS reads that attribute table is a table. So, for example, did you like a Control T or something? So in the Excel, when you hit the shortcut Control T, that's convert this spreadsheet to the table. Okay, so table and spreadsheet is slightly different, and the way GIS read attribute table is a table, not the spreadsheet. So it's just slightly different. Okay. Anybody has any other questions? Any other comments about the contents that we exercised today? Thank you. Thank you.